So good morning. Second year Bcom computer applications, second year Bcom computer applications and second year BA computer applications, semester 3 Rdbms. Important topics, revision of important topics, data models, introduction to databases and Dbms or Rdbms, and data models, different types of data models, different types of database views అనేది డిస్కస్ చేద్దాం. So starting with the introduction to Dbms. So what is the Dbms and what are the features and applications, what are the different types of views like that. So Dbms means database management system. It is a one of the Rdbms or Dbms package system. It is an engine, mainly it is engine or application software used to run all the any database management system or Dbms software like Oracle, MySQL server, SQL server, MS Access like that. So what are the main applications of Dbms? Telecom industry, in banking systems. అంటే మనకి చాలా రకాల డేటాబేసెస్ ఉంటాయండి. we may use there are many types of database vendors like Oracle, SQL server, DB2, MySQL, MS Access. So there are many types of databases and databases servers are used. So applications of Dbms are mainly in telecom industry, banking and sales, airline systems, reservation system, education sectors, online shoppings. మనకి ప్రతి చోట కూడా DBMS అనేది మనం మెయిన్గా వాడతాం. So what are the drawback systems of file based management system? File based system means earlier we may use file based system instead of Dbms. So it contains many drawbacks or it contains many pitfalls. What are those? Data redundancy. Redundancy means duplication of data. Data redundancy means repetition or duplication of data. And data inconsistency. Inconsistency means incomplete. Inconsistency means incompletion of data. Means the data or information in the file based system or in the previous databases, it is inconsistency. It may lead to inconsistency due to redundancy. Means incomplete, means not properly connected, not accurate and not fulfilled. Next is data isolation. Means it is in data is maintained in various formats, in various applications and various file formats, and so that it is also one of the pitfall of Dbms in file based systems. And dependency of application programs. So another pitfall is application dependent on application programs. Means various application programs may use various Dbms files and various Dbms softwares, so that there should be there is no centralized database system. So that another problem is using various application programs and with various database systems. And atomicity problem. Atomicity problem means security. Another pitfall or another drawback of ordinary file system is security. Data security means there is no proper security and there is no proper data user management like that, and there is no proper levels of users are maintained like that. So what are the advantages of Dbms over file based systems? Means no redundancy of data. Means there is no duplication of data, there is no replication of data. And data consistency and integrity. Consistency means it is 100% accurate and it is 100% connected with all the files and all the parts of the database. So it is it is properly integrated with all the other parts of the data or information. So it is consistency. And data security means in DBMS we may have various options, security options, like maintaining various levels of users, different database DBA means database administrators, and top level users and bottom level users and users. So security is another important feature of DBMS, any DBMS. Privacy means limited access, means we can control the accessing to various users, various levels of users, means some portion of data can be viewed and users, and some portion of data can be viewed by managers only. Like that we can protect data or information by unauthorized users. And easy access to data means we can easily access any data or information or table by using, means that the same data or information can be accessible by various levels of programs, means different levels of application programs or different levels of applications can be accessed same data or information, so that we may use the same data or information by many number of application programs or many number of programming languages like Java, .NET, like that. Easy recovery means another important feature of DBMS is recovery of if there is any database loss or any database damage or corruption or corrupted data, we can easily recover it to its previous stage. Flexible means we can easily flexible all the DBMS systems and softwares. So, and disadvantages, what are the disadvantages? Means cost is high compared to ordinary file systems, means we may purchase or buy original softwares from vendors. Complexity means it is not easy to understandable. Performance, so performance issues are also there. So next important concept is DBMS architecture. So what is, how the DBMS is created and how the DBMS engine is working, what are the different components of DBMS or different parts of a DBMS engine, like that we may discuss all these things here. So DBMS structure or architecture, what is the DBMS architecture or a structure? So different types of DBMS architectures. So basically 3 types of DBMS architecture are used. First one is single tier architecture, 2-tier architecture and 3-tier architecture. Single tier architecture, 2-tier architecture and 3-tier architecture. So single tier architecture have only database engine is available, no other parts or components are used. But in 2-tier architecture we may use client server technologies. In 2-tier architecture, so there are basically 3 types of architectures are there: single tier architecture, 2-tier architecture and 3-tier architecture. So in 2-tier architecture the diagram is like this. We may use client server technologies. So server machine is DBMS or DBMS software is installed in server machine by using some network connections. The clients can access the DBMS via networks, cables and wireless and other technologies. So in clients generally we may use clients may use DBMS users and other DBMS applications over a network. The database complete database is installed at server side system. So in 2-tier architecture, the database system is present at the server machine and the DBMS application is present at the client machine. So the server, the database server or DBMS server is totally installed at DBMS server machines, whereas applications, DBMS applications or application programs or application softwares are accessible via client machines. So these two machines are connected with each other through a reliable network as shown in the above. So the clients are generally connected with networks by using some cables or by using some wireless technologies and others. Whenever client machine makes a request to access database present at server using a query language like SQL, the server performs the request on the database and returns the result back to the client. So by using some application programs or any programming languages at the client machines, generally the clients or end users or application programs give a request to access a database or some queries or some records over a, generally they send a request over a network, and the server will respond accordingly. The server will respond accordingly and send back the results or records back to the application program or client machines. The application connection interface such as such as JDBC, ODBC are used for the interaction between server and client. So there are different types of connections are established, like ODBCs, JDBC connection for Java based applications, ODBC connection for Microsoft applications, to establish a client secured client connection from the client machines to the servers, databases at the servers. So the next model is 3-tier architecture. The next model is called as a 3-tier architecture. What is a 3-tier architecture? Generally in 3-tier architectures, the diagram is like this. In 3-tier architecture, we are using we are having database systems, server systems, server database DBMS applications. We are having 3 servers or 3 layers. The one layer is at client side or client machines, and the second layer is for database systems or DBMS software, and third layer is for applications, DBMS applications or application programs. So here there are 3 architectures or 3 layers are used. One is for client systems, and second one is for presentation or application systems, and third one is called as DBMS server systems. So by using client machines, generally client machines have some database users. They can be accessed database by using some database users and application programs over a network. They can directly communicated with server machines. Basically 2 types of servers are available. One is used for presentation server or application server, it having all the application programs, whereas the second server second server contains original database system. So this type of architecture is called as a 3-tier architecture. So in 3-tier architecture, another layer is present between the client machine and server machine. In this architecture, the client application does not communicate directly with the database systems present at the server machine. Rather, the client application communicates with server application, and the server application internally communicates with the database system present at the server. So in 3-tier architecture, there are 3 layers or 3 servers are used. Only in one first layer, client layer, generally clients are communicated with the server databases or the application programs, and from the application programs it is communicated with the database server. So this is the 3-tier architecture used. So what are the different architectures or layers? What are the different DBMS architectures are used? Views are used, different levels of views or different levels of architectures are used. Generally DBMS architecture contains 1-tier, 2-tier and 3-tier applications. We will discuss 3 levels or views of DBMS architecture in detail. So what are the DBMS 3-level architecture used, and what is the diagram? So this is the diagram used for 3-level architecture. So what levels here, it is called as external levels or views. Levels or views. So in the 3 level DBMS architecture, there are 3 levels: external view or external level, conceptual level or conceptual view, and third one is internal level and internal view, and physical databases. So this is the another diagram, architecture diagram or block diagram, another architecture of a working of a DBMS engine. So in this view, there are 3 layers or 3 levels or views. First one is called as external view or external level. The second one is called as conceptual view or conceptual level. Third one is called as internal level or internet level. In external level, various application programs and various programming languages and various end users, customers are trying to access the database through some application programs or through some programs. In the conceptual view, it is also called as a logical view of a diagram. It is also called as a logical view of a diagram. In the logical view or a conceptual view, all the how the database is designed and how the data or information is flows, all these things are explained. And in the internal view, the physical database is defined and like tables, databases, tables, fields, structures, constraints, indexes, all are defined at internal view. Internal view is directly connected with the database, that is the physical view of the database. So this architecture has 3 levels. First one is called as external level or external view. Second one is called as conceptual view or conceptual level. The third one is called as internal level or internal view. So what is external level? External view, in it is also called as external level, external view. It is also called as external. It is also called as a external view because several users can view their desired data from their level, which is internally fetched from the database with the help of conceptual and programming internal level mapping. The user doesn't need to know the database schema details such as data structures, table definitions. User is only concerned about data, which is what written back to view. So external, in external view, we may use application programs and users, end users. See in this diagram, in the external view or external level, application programs or application users, developers, and end users, customers are access the database directly without knowing the original structure of the database or original architecture of the database, like that. So they can be easily accessible, directly accessible the database by using some application programs or by using directly. So in the conceptual view, second level is called as conceptual view or conceptual level. In it is also called as logical level or logical view. The whole design of the database, such as relationship among data, schema of data, etc., described in this level. So database constraints and security are also implemented in this level of architecture. This is maintained by a DBS. So what is conceptual view? So the second level is called as conceptual view or conceptual level. First level is external level, second level is conceptual level or external conceptual views. In conceptual views, all the logical database designs are existed. Means what are the relationships between among various tables or databases, and what are their indexes, and all the other DBMS related operations are defined here. So like security issues and like user level management, means user level means different levels of users with different security levels, and all these things are generally defined at logical conceptual view or logical view. It is also called as logical view or conceptual view. So the whole database design is created at this level, like including creating relationships, schemas means structures. What is the database schema? Schemas means describing about or creating and describing about database structures. And database constraints means various levels of conditions. Database constraints means various levels of conditions and validation checks. For example, if you create a student database giving some primary hall ticket number is a primary key, it is a constraint. Constraint means, what is a constraint? Constraints are some set of rules and regulations which are governed and applied at the time of database or table design only. Means, for example, hall ticket number is a primary key. What is a primary key? A primary key should be unique, should be taken as unique, and it should not be any repeated values, and it should not be taken as any duplicate values like that. It should not accept any zeros, blanks, null values like that. So database constraints and securities, various levels of securities, username, credentials, users, user grants, and their rights, all are DBS, DBA level users, ordinary users. All levels of securities are also defined at conceptual level or logical view. Okay. The third level is internal view. What is internal view? This level is also known as physical level. Internal view or physical level. This level describes how the data is actually stored in the stored devices. This level is also responsible for allocating space onto the data. This is the lowest level of the architecture. So the third level is internal level or internal view or physical level. So there are three views or three levels of database are there. First one is external level or external view. Second one is logical level or logical view or logical level or logical view. Third one is internal view or physical level. Internal level or physical level or internal view or logical view or internal physical level. So in internal level, all the physical databases are designed, like database tables creations, database schema creations, table structures, and all the things are defined here. So in the physical level, how the data is actually stored in the storage devices, means which type of storage media is used, and magnetic tape, discs, magnetic drums, like that. And also allocation of spaces, different spaces or storage media, and all these things can be used at defined at the internal level or physical level. So and in the physical level, the original database or original database application is databases are directly accessible in the physical level or from the internal level. So this is the working of a architecture of a databases. This is called as architecture, Dbms architecture. So how the different views are connected, views are connected in Dbms. So in this diagram you may see here view 1, view 2, view 3, view n, or user 1, user 2, user 3, and logical level and physical level. Three levels of data abstractions: physical level, logical level, and view level and examples. So in physical level, original tables and original database tables and original table schemas, database structures are defined, and in logical view all the relationships and all the database designs and different levels of securities, different user management, all these things are defined in logical view or logical level. And in the conceptual view or in the so this is the architecture of a Dbms engine, working or architecture of a Dbms engine. Okay, thank you.